Ti z vás, kdo chodí na naše webináře pravidelně, tento slide již znají, nicméně nikdy si ho neodpustím. Je to takové rychlé představení, co vlastně za společnost M-Computers děláme v oblasti NVIDIA. Dosáhli jsme v této oblasti nejvyššího partnerství, je to partnerství Elite a to nám umožňuje dodávat veškeré high-endové produkty společnosti NVIDIA. Máme vlastně jak klasickou certifikaci Compute DGX, která nám umožňuje dodávat DGX zařízení, superpočítače DGX, tak i certifikaci Visualization, díky které vám můžeme dávat RTX karty za projektové ceny. A nově jsme tento rok získali i certifikaci Virtualization, která pokrývá veškeré produkty, veškeré licence pro virtualizaci grafického výkonu. Ještě bych ráda zmínila, že máme poměrně velký pool demotechnologií, nejen tedy zmiňované karty a DGX zařízení, máme i nejnovější DGX Station, ve které jsou akcelerátory A100, což jsou vlastně vlajkové lodě společnosti NVIDIA, tak právě i díky společnosti Asbis máme k zapůjčení i zmiňovaný BlueField-2 DPU. Takže pokud byste měli do svého projektu nebo do své infrastruktury zájem otestovat tuto kartu, můžete se na nás obrátit a můžeme dohodnout zápůjčku. A v rychlosti, čemu se tady budeme dneska věnovat? Jak jsem ji zmínila, budeme se věnovat tomu, co vlastně vůbec znamená DPU, co tato zkratka v tom NVIDIA nebo obecně v tom hardwarovém světě znamená. Budeme se potom zabývat nejenom technickými specifikacemi, ale i například softwarovými sadami, které potom můžete využívat ve spojení s tímto hardwarem. Podíváme se taky na roadmapu, co můžeme čekat do budoucna, jaká ta generace je právě aktuální, jaká přijde příští rok a možná i ty další roky. Zmíníme několik pojmů, které se k této tematice úzce vážou. Bude to například projekt MONTEREY. Zmíníme určitě také příklady nasazení, abyste si mohli trošičku představit i, co to v reálu znamená, jak se využívají tato zařízení. A v druhé polovině prezentace si ještě ukážeme, co momentálně nabízí portfolio networkingu od NVIDIA, kterou jistě víte, NVIDIA, která koupila v minulém roce, tuším, to bylo předminulém, firmu Mellanox, takže vlastně switche, které znáte pod názvem Mellanox, tak teď už hrdě nosí značku NVIDIA. No a abych nezapomněla, celá tato prezentace, celý tento webinář bude zakončen kvízem, takže dávejte pozor, ceny jsou hezké. Tady jsem dala obrázek té první ceny, bude to krásný 15letý rum, který nám poskytla společnost Asbis, takže když budete dostatečně rychlí a budete dávat pozor, tak si ten rum můžete odnést. Tak a já bych teda teďko předala slovo Sebastianovi. Sebastian, can you hear us?
Yes, I can hear you.
Okay, perfect. The stage is yours and I will give you the screen.
Perfect, thank you. Let me put my slides up. So I hope you can see the slides. Great. So thank you for having me. Thank you for the introduction. To be honest, I did not understand too much, but what I understood is that you already explained that NVIDIA Networking Business Unit or NVIDIA Networking is what you all probably formerly know as Mellanox Technologies, a networking company which was well known in the market, and we have been acquired by NVIDIA last year, and we are now NVIDIA Networking. And I'm Sebastian Kalcher. I'm system engineer or solution architect, however you want to call it, in the networking unit of NVIDIA. And I've been with Mellanox and NVIDIA now for over 5 years. And I will try to tell you a little bit about data processing units today. And the second part will be about Ethernet switching. We, of course, have other networking products as well, like InfiniBand, for supercomputing, high performance computing. We have also regular networking card, NICs for Ethernet and InfiniBand. We have cables, we have transceivers. We have a whole portfolio, but today we want to focus on these two interesting topics. And data processing units are something new. Let me just move that screen a little bit. Are something new, and where it fits in, you can see here in this slide. So that's our vision of the data center, of the new data center. We have, of course, the CPU in that triangle on the bottom, which is, as always, responsible for more the sequential tasks. And then we have the GPU for the massive parallel accelerated computing tasks. Those are not new. Those are there for years now, of course, or forever in terms of the CPU. What is new is the data processing unit to the right. And this is a specialized processing unit, which is focusing, or which is responsible for doing all kinds of data intensive tasks related to communication, so networking, but also security, which can mean encrypting and decrypting these very fast data streams, and also storage. And how that really works and how that is really supposed to fit in, we will see in the next couple of slides. A little bit for the motivation of a data processing unit. We've seen in the last couple of years the standard architecture in the cloud or in the data center itself, where everything became software defined. So you have your regular server with your workloads, could be virtualized, could be VMs, or you're running a ton of containers. And then you have a bunch of software components related to the software-defined world. That could be software-defined security, so firewalling, packet inspection, all kinds of security-related things, then software-defined storage, of course, and software-defined networking. All these components, or in addition to that, you have some more general infrastructure management tasks, which also consume cycles on your server in that architecture. Yeah, and all these components, they sit or they live on the same machine as your workloads, as your user workloads, and they consume cycles. And over the last years, the amount of CPU cycles they are consuming has increased more and more. All of this sits typically on top of an already high-performance NIC, so a network interface card, which already has a ton of acceleration engines to do crypto or to TCP acceleration, all kinds of nice little acceleration engines. But still, the idea of the DPU is now to take all these software-defined agents, software-defined components, and move them down onto the networking card. So take infrastructure management, security, storage, and software-defined networking elements, and move them away from the x86 CPU or the main server CPU and put them on the very powerful networking card. That has two benefits in this case. Of course, you free up your main CPU, so you can run more VMs, you can run more containers on the same CPU, on the same hardware. You move all these infrastructure tasks somewhere else. And the other benefit here is really that you move these infrastructure components into an isolated system, which is not accessible to the user running on your main CPU, on your main server CPU. So it has some security implications that you secure your control plane against attacks in this case. And these are the two main benefits. How does it look? How does a DPU, this data processing unit, really look? It's an SoC. And just to introduce the name here, we call our DPUs BlueField, and we are already at the second generation. So BlueField-2 is the current generation of the DPU. So BlueField is our marketing name for it. And you see, as you see on the right side in this colorful die shot, it's an SoC, so it's a system on chip with different components. And the most prominent and the biggest one is, of course, here in purple, the networking subsystem. As I said, we still need a high-performance networking card. So in this case, it's ConnectX 6DX. You might know that all our regular networking cards are called ConnectX, and 6DX is kind of at the moment, the most prominent, most powerful networking card we have in the portfolio. ConnectX 7 will come soon. So the biggest part here really is ConnectX 6DX. It supports up to 200 gigabit Ethernet or InfiniBand to the networking side, but you can also, you can either have, in this case, one port of 200 gigabit, or you can 2 ports of 100, but you can also do 50 or 25 or 10, whatever you like. So there's different form factors for different networking speeds. And ConnectX-60X already has a bunch of acceleration engines in it, as I told you. And one of the most important ones is a crypto acceleration engines. So you can do IPsec encryption in hardware in the card, and you can also do SSL TLS encryption within the card. So you can move these AES encryption tasks from your CPU in the networking card. The real programmable part, or the real processing part here, are then the ARM cores. These are the blue box here, and we have up to 8 ARM A72 64-bit ARM CPUs in here, which can be clocked up to 2.75 gigahertz. So really quite a bit of compute power for a networking card in that system. It's not fully comparable to the server CPU, but you see it's 8 cores with up to 2.75 gigahertz. So, and it's running its own Linux system. It's shipped with Ubuntu 2004 Linux running on there. And yeah, and that's where you run your control plane components and where you do all the magic of the DPU. But you don't only have these programmable ARM cores to run your workloads. You have some dedicated acceleration engines, the blue boxes, the green boxes. And for instance, we have a regular expression engine. So you can have like a pattern matching engine, which can be used, for instance, for deep packet inspection, which can inspect, search for patterns in packets, for instance. So you immediately see application here for security. You also have a compression and decompression engine, which can be used for storage applications. So you can do compression and decompression on the fly. And we have a SHA engine. We have a SHA signature engine, which can be used for deduplication, also for storage applications. So these are in the green boxes. And of course, the ARM cores have their own DDR4 memory channel, and the memory interface is sitting on here. And the whole system is connected internally via an integrated PCI Gen 4 switch. And this Gen 4 switch has still 16 lanes free, which can then be used to connect the whole system to the main server. And in the end, it looks like a networking card. You see a little bit blurry in the background. You have your high performance ports, typically QSFP or SFP, some kind of variant. And then you have an additional 1 gigabit out of band management port where you can actually reach the DPU out of band and manage the whole system out of band. All right, so that was a lot. That was a lot in one picture. The important question is now, how do you use it? How do you program it? How do you put stuff on it? How do you orchestrate your workloads from the DPU side? As I already told you, there's a Linux running on it, more or less standard ARM Ubuntu 2004 on it, but still you want to use all these nice acceleration engines and crypto engines and SDN engines which are on there. And the answer here is NVIDIA Docker. And Docker is a software framework. You see it here in the green box, which contains of libraries, drivers, components and reference application, and components for telemetry management and orchestration. So it's a whole package. An application framework for really putting applications on the DPU. And we kind of imagine Docker is for DPUs what CUDA is for GPUs, if you're familiar with the CUDA framework, how to program GPUs. So it's a rich application framework ecosystem which allow you to program the DPU, and it kind of protects your investment. So even if in a further generation of the DPU, some hardware changes or it looks a little bit different, Docker will be the abstraction layer, so you're guaranteed that your software will still run on the DPU. We have, same as with CUDA, we have some reference applications which can really serve as a good starting point to create your own applications. So we have some reference applications for firewalling or for deep packet inspection. And we're getting more and more of these applications with every release of CUDA. So you can really get started to put the DPU in use. And it eventually will really serve as, or will help create this rich ecosystem across many industries and workloads. And on the top of that green box, you already see a lot of companies which are already working with Docker and to provide their solutions. And we have, of course, on the infrastructure side itself, Canonical, which provides, and Red Hat, which provide here the operating system, and VMWARE. You have a look at Project MONTEREY, something which is coming in the future. We have a lot of cybersecurity vendors which already put their firewalling, deep packet inspection, or separation tools on there. We have a lot of networking companies who put their cloud networks or load balancing or these kind of, or in the process of putting it on there. And we have a bunch of storage providers which work on, using the storage capabilities of the card. And here's a little bit of the vision that we, of application and software-defined workloads that we see running on the DPU in the future. It's separated in these three segments. We've seen software-defined networking, storage, and security. And it's not too surprising because it's a very powerful system with our standard Linux on it. So we see vRouter, vSwitching, streaming, load balancing, acceleration of VM and container networking, which is something that most of our cards already do, but also some telco use cases. For software-defined networking, we have in the storage side, NVMe over Fabric, and that's something I haven't talked about it yet. So the DPU has the option to mount a remote NVMe over Fabric targets on the DPU side, and then expose it to the host side as a local, so simulated as a local NVMe device. So the local user does an LSPCI, and he or she sees a local device, a local NVMe disk, but in reality, it's a network storage device, which is kind of emulated by the DPU. We can do encryption, decryption of storage on the fly. We have this elasticity because we can now add to your server a storage element, which is perfectly sized to the needs of the user, and it looks really like a local device to the user, but it's somewhere in the network. And of course, you can do compression, decompression, and deduplication. I already told you about these engines, which are on the card that can be done on the fly. And on the security side, of course, we can do firewalling, we can do intrusion detection and prevention. Microsegmentation is another use case, and DDoS prevention. Of course, we can mitigate against DDoS attacks in hardware. And last but not least, root of trust means that there's a lot of the platform itself is very secure against all kinds of attacks, even hardware attacks, so supply chain attacks. We have secure firmware update and secure boot. All these kind of elements to harden the system are hidden in that segment. I have a few more examples, which are already partly mentioned here. For instance, bare metal clouds, of course, is such a thing where you give away your cloud computer, but without a hypervisor. You give freely away your hardware, your bare metal hardware computer, but still you keep your complete control over the system, even though there is no hypervisor or other software running on the server. Because you have the DPU as a security element in here. So you can have full control over the network via orchestration, via OBS or OBN, for instance, and there's no drivers needed on the bare metal host. You have full control over the storage. So you have fully virtualized storage. As I told you just a slide ago, you can emulate like a local storage device to the user, but in reality, it's coming somewhere from the network. And of course, we have full zero trust security, meaning that the tenant's workload or the user workload is fully separated from all kinds of data center security agents and software which are running somewhere else. And one example of such a cloud solution is then VMware's Project MONTEREY, and where they just about to do exactly those things. They take like these infrastructure management components from the host, from the virtualized host itself and move them down to the BlueField-2 DPU. So your NSX, your firewalling, your vSAN, and your other management components, and only leave some of the hypervisor components on the host side or on the server side, or even will then be able to move everything down to the DPU and really manage a bare metal server with whatever operating system you run on there, basically in a similar fashion like your virtualized server. And this is really an interesting development that we see from VMWARE, as said, Project MONTEREY, but it's also, of course, a very hot topic for all other cloud and data center operators. So what you get is, of course, optimized performance, because you move all these software components down to the DPU, and you free up your cycles on the server itself. But you keep all your unified, consistent operations, your management tools, and everything that you're used to. You have zero trust security model through that separation, and you really can create an application-driven infrastructure, meaning that you can really adjust the infrastructure to the needs of the actual user. Very similar. This also is raising a lot of interest in the supercomputing side, where you, of course, don't have hypervisors and don't have these cloud frameworks, but you have other software components for distributed applications and distributed storage. And what we see here is that it's basically happening the same. All these components which typically use up cycles on the server side, on the server CPU, are moved down to the DPU and can now do their work asynchronously and free up resources. Then cybersecurity itself is, of course, an interesting topic for the DPU. I already mentioned platform security. So it's a very secure device. It's a very hardened device with secure boot and secure firmware update. But of course, we have these nice crypto acceleration engines in the ConnectX-60X, so you can really accelerate your IPsec tunnels, or you can accelerate your application TLS application delivery. I don't know, web servers or reverse proxy, load balancing, encryption, and of course you can on the software-defined networking part also use these hardware engines to have very high performance security policy enforcement on the lower levels. We have this regular expression engine in the acceleration package, which can really be used to do a deep packet inspection. So you can search for patterns or attack patterns or malicious patterns in your traffic. And not do that in software on the CPU. Last but not least, the isolated security control plane is, of course, a big benefit, that you can really move all these components away from the user and put it into an isolated system. So the DPU, the Linux running on the DPU, is not accessible to the user from the host side, and of course that's a big plus. And just one quick outlook on the 5G side. Of course, all these nice benefits for software-defined networking or for cloud-native accelerations of virtualized network accelerations or container network accelerations are very important as well for modern 5G networks. And additionally, these cards are can perform a very accurate time synchronization, which make them also very helpful in these kind of systems. But that's a whole talk by itself, just to give you a quick outlook. So we talked up until now about BlueField-2, so the current version of the DPU. And we already gave a little bit of a preview of the next generation of BlueField-3 DPU, which will be the first DPU with native 400 gigabit networking. You see, it's quite a big device, 22 billion transistors, 400 gigabit Ethernet and InfiniBand connectivity, as opposed to 200 gigabit, which we have now on the BlueField-2 DPU. Everything is a bit more balanced with that next version, which is coming somewhere next year. So we have full 400 gigabit crypto acceleration. We have now 16 ARM cores. And of course, we have the overall performance benefits scale very nicely with this new hardware. The use cases are very much the same as for BlueField-2. So cloud computing, talked a bit about it, cybersecurity, but also HPC and AI acceleration. There we'll see something interesting for true tenant separation, also for these compute and AI systems, telco, storage, and also media and streaming. So it's a bit of a Swiss Army knife, I always say, because it has so many hardware accelerations, but also you have these 8 or 16 ARM cores where you can run your own software and perform your own interesting use cases. And actually, every time I talk to customers, they are adding use cases and they're adding interesting stuff you can do with it. Here's a little bit of comparison between BlueField-2 and 3. As I said, I don't want to go too into detail, but you see 200 gigabit now, 400 gigabit in the future. Of course, we have better packet rates, we have more compute, we have more balanced crypto acceleration here. And for the first time, we will offer MaxSec acceleration on BlueField-3, meaning we have really acceleration crypto on layer 2. And NVMe Snap, this is the feature which exposes the storage as a local device, even though it's somewhere in the network, which will also get a performance bump in this case. And what we see now is that there's really a broad partner ecosystem developing. So lots of partners see the value of the DPU. I already mentioned a few of them, and put their software on it, either their operating systems or their application software or their hypervisor, and see it as an important infrastructure component in the future. We see here in the lower part a bunch of storage providers which exactly do that, what I described, that they mount their storage, distributed storage, which sits somewhere in the network locally on the DPU, and then expose it to the user. This has also been shown before, I think at the last GTC or the one before, just to illustrate that we really are serious about the DPU. So we already give a even further roadmap outlook. At the moment we are here, BlueField-2, and BlueField-3 will come next year with that bump, with the performance bump we've already seen. And we already gave a little preview on the next generation, which will then come with a very nice cadence of 1 year, maybe 1 year later. It will be much more powerful. Again, so we're really serious about this. For us, this is really a critical component to scale up these networking or general accelerated compute in the data center. And with that, I want to close the DPU, the quick look at the DPU. I know it's a lot. It's a completely new topic, and I only could give you a little glimpse. But we also wanted to have a little bit of a look at the Ethernet switching side, so the other aspect of the Ethernet data center, and that's what we want to do now. So NVIDIA networking, as I said, came from Mellanox technologies, and then almost at the same time, NVIDIA also acquired Cumulus Linux, which has been a Linux-based operating system, or which is a Linux-based networking operating system, which has been running on our Mellanox switches already for quite some time. And now we come together and build a very powerful combination under the NVIDIA networking brand, so to say. And there are some aspects, or there's multiple aspects, not only the hardware, not only the software, but some other parts which come together, which make it more than the sum of its parts, so to say. So let's have a look at some of the operational efficiency benefits which we can offer at the moment with Cumulus Linux. And so we have a full NetDevOps CI/CD pipeline implemented. So what you can do is you have your physical switching network here, and you can create like a digital twin in the cloud or on premise, and you can simulate your full network in this digital twin. You can do validation. You can check changes you want to apply to the network. You can validate changes. You can do analysis of your network. And once you've done that, you can roll out these validated changes and these validated updates into your physical network, and then you can import your changes back, or your measurements or your telemetry back into your digital twin, and have this cycle, the CI/CD pipeline for Net DevOps. This is already possible. You can already get started using NVIDIA Air, which is a simulation environment to exactly do that, to take your existing network and create a digital twin and perform some simulations and some work on your digital twin, and then use that the knowledge or the configuration you created on your digital twin and roll it out to your physical infrastructure. But Cumulus Linux is not the only operating system that can run on our Ethernet switching hardware. So traditionally, we've been a proponent of Open Ethernet, meaning that we had our own, or we still have our own network operating system called Mellanox Onyx, which is also a commercial operating system, which is doesn't have that Linux look and feel as Cumulus. It's not as strong in automation and some other parts, but it has this more old school industry standard CLI and strong RoCE implementation. So RDMA converged Ethernet functionality for storage, for instance. And so this is still available. Of course, we have Cumulus Linux with all these nice benefits, and this is really kind of the star at the moment. But we also allow, for instance, other free and open source operating systems to run on our switches. So Sonic is one example from Microsoft, which can be run on there, and you can also take more or less a standard Linux distribution and put it on there. But then, in terms of support, you of course have these three options to run software on our switches. Yeah, let's have a quick look at the hardware itself. Here's an overview of the portfolio, of the current portfolio, or a little bit also an outlook of what's coming. We have now multiple generations of ASICs, switching ASICs, and that's the very important point. So NVIDIA, Mellanox, NVIDIA Networking produces their own switching ASICs on the Ethernet side. So we're not buying merchant silicon in this case. So this is our own silicon, which is running on there, and we have multiple generations, which are called Spectrum 2, 3, and 4. You see it on the part numbers. And our portfolio is getting broader and broader. And if you start a little bit at the left side, we see that we have this very nice half-width switches. So we have 16 ports of 100 gigabit, and it's only 19-inch half-width. So you can put two in one height unit. And we have a more storage-oriented switch, which has 18 times 25 G ports and 4 times 100 G port uplinked. And soon there will also be a dedicated 1 gigabit switch with our Spectrum ASIC coming. Then in the middle, we have these classical leaf spine switches and various form factors. You see the typical 48 times 25 or 48 times 100, and then some higher uplinks, so 8 times 100 gigabit uplink, or 12 times 100, or 8 times 400 gigabit uplinks. And also a large modular system, which is coming. Then we have the other typical flagship models with 32 times 100 or 64 times 100. And then also 400 gigabit in various flavors. And at last, we have some column here, which we call AI switches, which already give you 200 gigabit, 32 times 200 gigabit, or 64 times 200 gigabit for really the connectivity for these AI kind of servers, like heavy GPU servers like DGX i100 or other GPU servers, which really need these high bandwidth down to the server. So you see we have a very broad portfolio, which is getting broader and broader with the time. And as I said, it's all based on our own ASIC, and that has some important consequences, which we can look at now. So our own ASIC has some performance characteristics which are very notable and very important for these typical data center workloads. For instance, we can show that we have a superior burst absorption or absorption of microbursts, meaning that if multiple clients connect to a storage server, for instance, then you have a many-to-one connection, which creates these microbursts. And the better the switch can absorb these bursts, or the higher these bursts, or the larger the bursts are that can be absorbed by the switch, obviously it is better for the application, because then the switch doesn't have to drop packets and everything runs smoothly. We have a very important feature regarding fair bandwidth sharing. This is related to our buffer architecture, and I have a separate slides for that, meaning that we can guarantee that every port gets a fair share of the bandwidth, which is of course very important in a multi-tenant environment. And of course, also latency is very important. We've always been the leader kind of in latency. And if you look at the latency distribution over the packet sizes, then you see that we have a very flat latency curve, which is always lower than the typical competition in this case. There's one more slide for this buffer architecture to illustrate that a little bit better. So as I said, we have a fully shared buffer. So all ports are serviced by one big buffer, which means that in every constellation and every situation, like all ports get a fair share of this buffer, and no port is kind of has an advantage here. And for some of the merchant silicon chips, you can see that depending on where the port is connected, it's getting a different slice of the buffer inside the ASIC architecture. And then this results in some unfair bandwidth sharing, meaning that one port gets more than the other port. And this is also not just a theoretical thought experiment. You can really see it in the wild. There's papers, there's academic papers, but there's also papers by Facebook and others, which have really seen that and described the adversarial effects of this architecture. So this is an important issue or an important point when you select your switching hardware. And as a last point, I want to look a little bit more at visibility, at advanced telemetry, kind of the next to the hardware itself and the operational efficiency, the other very important point in the modern data center. What kind of tools do you have to monitor your network, and for instance, and especially to deal with errors. And so we have an interesting hardware feature in the ASICs, which is called What Just Happened. So it's a very instructive name. If you observe some kind of issue in your fabric, here you see again your switching fabric, your spine fabric, and something is happening. Some packets are dropped. There's a data plane anomaly, and what you typically have to do, you stream out your SNMP data, your syslog data, your flow monitoring data to some central database or logging instance, and then your sysadmin or your network admin has to kind of identify the time, roughly the time where this incident happened, and then has to go through all these logs and look for the needle in the haystack, so to say, and try to find out what happened. Why was the packet dropped? Why did the application have an issue in this case? And what just happened has kind of a completely different philosophy. We integrated this in our hardware, so it's really a feature of the switching ASIC itself. Whenever the ASIC has to drop a packet or has to seize a data plane anomaly, in this case, the ASIC knows the best why something happened. For instance, that can be something simple as like the VLAN was not configured, or it's a wrong VLAN, so it had to drop it, or a wrong MAC address, or all kinds of like typical reasons but it can also be something more complicated related to the routing protocol or whatever you can imagine. But in any case, the ASIC itself knows pretty well what was going on. So what just happened is a feature where the ASIC itself takes the packet's headers and the detailed description of the incident and only transmit this kind of information, this what just happened information, to a central logging instance and creates this alert. So the network admin, the sysadmin, gets a very pinpointed alert and message with a human readable detailed description what was happening. And it turns out this is very, very helpful to debug and diagnose your networking systems. You don't have to go to the haystack anymore to find the needle. You get the needle kind of presented by your switching ASIC itself. So this is a very powerful tool. And yeah, last but not least, we have on the Cumulus side a tool called NVIDIA NetQ, which really helps you to implement automated change management with NetDevOps. So it's a piece of software which performs telemetry collection and network analysis, and can then also perform this kind of change validation with your digital twin. So in your simulation, and once that all automatically validated and checked, it can roll out these changes to your network. Yeah, so to summarize all this, we can really present here a cloud scale networking stack, which consists, of course, of superior hardware, our Spectrum ASICs, and multiple generations with the lowest latency, the highest packet rate and buffer architecture that I presented to you. So the hardware itself, the underlying hardware, is best in class. Everything is built for automation. So we have NetDevOps really built in our tools, in our tool chain. And that allows you to implement all these automation in your production systems. We are using the best open source routing stacks with a large community and unparalleled feature velocity in our tools. We provide simple, robust yet simple EVPN solution also based on Cumulus Linux. You see here our much less configuration lines, but still very robust. We have this fabric validation mechanism available via NetQ, which is kind of gives you a turnkey solution. No tools you have to develop on your own to perform that. And in the end, we have these hardware accelerated telemetry features based on what just happened, which give you really an unparalleled view into your switching fabric and give you a very quick time or very short time to identify potential root causes in your network. Yeah, and with that, I went also very quickly through the Ethernet side of things, but we wanted to give you a quick overview of these sites, and both topics can be really looked at much longer. we can really zoom into both topics and have much more detailed discussions about it. But we really wanted to give you just a quick overview of the DPU and of our networking, Ethernet networking, data center networking products. And if you have any questions, I'll be happy to answer them now.
That's great, Sebastian. Thank you so much. It was wonderful how perfectly you fit within your 40 minutes. So it was great timing. And thank you very much for the whole overview. We have actually here one question, and maybe in the meantime, I can ask also the audience, and we have quite nice audience today. So thank you very much, everybody, for coming. So just leave your questions to Q&A section or to the chat. And we have the first question, and it's back to BlueField-2 chip. And I think it's a very actual one, because the question is, as of today, what are the top 3 scenarios of successful cases with BlueField-2? So if you know some maybe references and to like best scenarios as of today, what you are familiar?
Yeah, so the bare metal cloud scenario is really one of the most prominent ones, I would say. So you could count VMWARE, Project MONTEREY in that category. So in general, there's a lot of work going on for bare metal cloud. So that really cloud operators want to use the DPU as kind of a security anchor in the system, want to like move everything on the DPU and then give out the bare metal servers. That's something that's happening very much. The security side is gaining a lot of tractions. So having the DPU inspect all your traffic, which is going in and out, or having this kind of hardware-based firewall in there, or DDoS mitigation, I see a lot of that. Yeah, and the storage workload also is picking up a lot of speed at the moment. So we are still very early in the product life cycle of the DPU. It's a very new product, but there's a lot of work going on, and you will see and hear more and more about it, I'm sure.
Yes, actually, we are very much interested in VMware Monterey, because in the same time we are doing AI and HPC supercomputers. We are also active in this hyperconverged NCI HCI play. So maybe the question is, when should be the technology available, the Monterey, any expectations?
I don't have the newest updates on this, but I guess there will be some updates early next year, very early next year. And it was planned to have some kind of technology preview by the end of this year. But I guess we have to wait for VMworld to get some updates.
Absolutely. And it will coming soon. So yes, you're right.
Yeah.
You're right. Yeah, because except the demo that Kamala described, we have on NVIDIA, like DGX systems and accelerators. We also have, together with VMware, the demo at VMware site in the Czech Republic in Prague, with 4 systems, the rich configuration, with persistent memories, and we have the full VMware software stack, the cloud foundation suite. So we are also looking forward with the DPU, and maybe the next hardware upgrade of this VMware demo we have might be with DPU. That's why I'm asking. So it will be definitely a topic for next year. And we are closely cooperating with VMware. So definitely we will discuss this over next months and years.